Hello students, in previous e-lectures we have discussed all about relations and functions. I hope that you have tried the questions related to that topic. In this e-lecture I am going to start a new topic, inverse trigonometric functions. Let's recall about inverse of a function. Inverse of a function exists only if it is 1, 1 and onto, or we can say the function is bijective. Inverse of trigonometric functions. Trigonometric functions are periodic functions. We know that. For example, the value of trigonometric sine function starts repeating after every 2 pi radian. So in general, trigonometric functions are not bijectives. So their inverse do not exist. However, if we restrict their domains and codomains, they can be made bijective and we can obtain the inverse of trigonometric functions. Let's recall the domain and range of trigonometric functions. Domain of sine function is set R. Its range is close interval -1 to 1. Domain of cosine function is set R and its range is close interval -1 to 1. Domain of tangent function is set R except odd multiples of pi by 2 and its range is set R. Cotangent function, its domain is all real numbers except multiples of pi, but its range is set R. Secant function, domain is R except odd multiples of pi by 2 and range is set R of all real numbers except open interval -1 to 1. Cosecant function, domain is set R of all real numbers except multiples of pi and its range is R except open interval -1 to 1. Let's discuss about inverse of sine function. As we know, domain of sine function is set R of all real numbers and its range is close interval -1 to 1. Within this domain, sine function is not 1, 1. We can observe it from graph also. Value of sine 0 and sine pi both are same, so it is not 1, 1. So inverse does not exist. But if we take close interval minus pi by 2 to pi by 2 as domain of this function, then within this interval it is 1, 1. We can observe it from the graph also. Here, curve of sine function within the interval minus pi by 2 to pi by 2 highlighted with red color. In this interval it is 1, 1 and onto both. Not only in this interval, but if we take intervals like pi by 2 to 3 pi by 2 or -3 pi by 2 to minus pi by 2 or any other, trigonometric sine function is bijective. So on the whole real line, sine function is not bijective, but partially it is. So the sine function with domain as close interval minus pi by 2 to pi by 2 and range as close interval -1 to 1 is bijective, so its inverse exists. It is also known as arc sine function. So the inverse of sine function is defined from close interval -1 to 1 to close interval minus pi by 2 to pi by 2. Thus y is equals to sine inverse x if and only if x is equals to sine y and y belongs to close interval minus pi by 2 to pi by 2. So domain of sine inverse x is close interval -1 to 1 and range of sine inverse x is close interval minus pi by 2 to pi by 2, which is also known as principal value branch. This is the graph of sine inverse x function. It is highlighted in the closed interval minus pi by 2 to pi by 2. Also remember, sine function restricted to any of these intervals is bijective and its range is close interval -1 to 1. Therefore, we can define the inverse of sine function in each of these intervals. As we have many options for inverse of sine function, so close interval minus pi by 2 to pi by 2 near to origin is considered as principal value branch. Let's discuss about inverse of cosine function. As we know, domain of cosine function is set R of all real numbers and its range is close interval -1 to 1. Within this domain, cosine function is not 1, 1. We can observe it from the graph also. Value of cos of minus pi by 2 and value of cos pi by 2 both are same. So it is not 1, 1. So inverse of this function does not exist. But if we take closed interval 0 to pi as domain of cosine function, within this interval it is 1, 1. And range of the function is also equals to codomain. So function is bijective. Let's observe it with the graph. Here, curve of cosine function within the closed interval 0 to pi highlighted with red color. In this interval, it is 1, 1 and onto both. Not only in this interval, if we take the interval pi to 2 pi or minus pi to 0 or any other in this way, the trigonometric cosine function is bijective. So cosine function is not bijective on the whole real line, but partially it is. So cosine function with domain closed interval 0 to pi and range closed interval minus 1 to 1 is bijective. So its inverse exists and it is also known as arc cosine function. Cos inverse is defined from closed interval minus 1 to 1 to closed interval 0 to pi. Domain of the cos inverse x function is closed interval minus 1 to 1 and range of cos inverse x function is closed interval 0 to pi, which is known as principal value branch. This is the graph of cos inverse x function. Also remember, cosine function restricted to any of these intervals is bijective with range closed interval minus 1 to 1. Therefore, we can define the inverse of cosine function in each of these intervals. Next is inverse of tangent function. As we know, the domain of the tangent function is set R of all real numbers except odd multiples of pi by 2 and range of the function is set R. In this domain, this function is many 1. We can observe it from the graph also. The value of tangent 0 and tangent pi remains same. So function is not 1, 1, inverse does not exist. But if we take domain of tangent function as open interval minus pi by 2 to pi by 2, then it is bijective. So inverse of tangent function exists and that is defined from R2 open interval minus pi by 2 to pi by 2. Here domain of the tangent inverse function is set R and its range is open interval minus pi by 2 to pi by 2, which is also known as principal value branch, and this is the graph of tan inverse x function. Next is inverse of cotangent function. Here also we can observe that cotangent function within its domain is not 1, 1. We can observe it from graph also. So inverse of this function does not exist. But if we take domain of the cot function as open interval 0 to pi, then it is bijective within this interval. So inverse exists. So cot inverse is defined from R to open interval 0 to pi. So domain of the cot inverse x is R and range of the cot inverse x function is open interval 0 to pi, which is also known as principal value branch. This is the graph of cot inverse x function. In the same way, if we observe the cosecant function, it is not 1, 1 within its domain. But from the graph, we can observe that if we take domain of cosecant function as closed interval minus pi by 2 to pi by 2 except 0 and range as set R of all real numbers except open interval minus 1 to 1, within this mapping it is bijective. So inverse of cosecant function exists and domain of cosecant inverse x is here set R of all real numbers except open interval minus 1 to 1 and range of cosecant inverse x is closed interval minus pi by 2 to pi by 2 except 0, which is also known as principal value branch. This is the graph of cosecant inverse x function. Similarly, secant function within its domain is not 1, 1, so inverse does not exist. But if we take domain of secant function closed interval 0 to pi except pi by 2 and range as set R of all real numbers except open interval minus 1 to 1, within this mapping secant function is bijective, so inverse of secant function exists and domain of secant inverse x is equals to set R of all real numbers except open interval minus 1 to 1 and range is the closed interval 0 to pi except pi by 2, which is also known as principal value branch. This is the graph of secant inverse x function. So students, I hope that you have understood about inverse trigonometric functions. Learn the domain and range of these functions. In next class, we will discuss about properties of inverse trigonometric functions. Thank you.